Hello, hello. Here we are again. Today we're going to do perimeter and area on a Cartesian plane. That means on a graph. So what we're going to do is figure out how to find the area and perimeter of shapes that are drawn on a graph. So it's a little bit departure from the stuff we've been doing with the equations of lines, but it's still things on a graph. So we thought this would be a good place to put it in our units. First, let's consider these shapes. Trapezoid, no big deal. Pentagon, no big deal. And then the other pentagon is not a regular pentagon, but it has 5 sides, so technically it is still a pentagon. We have a formula for how to find the area of a trapezoid, but what we're going to have to do with shapes on a graph and do the area of odd shapes like this letter C, the other trapezoid, we're going to have to figure out how to draw auxiliary lines to separate these shapes into triangles and rectangles. Remember, rectangles include squares. So the idea here is to be able to break down our shapes to make right triangles if we can, especially since we're doing this on a coordinate graph. Using right triangles, we'll be able to count the base and the height to get the area. So for the trapezoid, I could cut it into like a rectangle in the middle, 2 triangles on each side. As far as the pentagon's concerned, there's a lot of different ways you could do it. What I'm envisioning is a triangle at the top, and then that puts a triangle and a trapezoid. So if I had enough information, I could do the area of the trapezoid, but I could split the trapezoid the way I did the first one by putting a height from each corner. And now I have 2 right triangles, a rectangle, and then a triangle where I could find the vertical height and the base. The whole idea when we're separating these shapes is to try to draw vertical lines or horizontal lines, because those types of lines, we can count their length exactly from the graph. So if we have vertical and horizontal lines, I don't have to use the distance formula to see how long they are. And I could use base times height divided by 2 if it's a triangle, or base times height if it's a rectangle or square. So similar to that, and thinking along those lines, I'm going to put a vertical line right through here. Gives me 2 right triangles and a rectangle. So we're going to apply this to a graph. Okay, so next, if you wanted to find the area of the shaded region, I think you've done this before. When I've done these lessons in the past, students had a very easy time doing the areas. So the area of a square or a rectangle is base times height. Some people would recognize the formula as length times width. So we have 1, 2, 3, 4 squares wide, 1, 2, 3, 4 squares high. So this is a square. So the area of the square, the whole thing, base times height, is 16 square units. Now what we have to do on the inside here is take out the area of the triangle-shaped hole. So I need the area of that triangle. And I know we did 1/2 AB sine C in the last unit, but that's when we have angle measures. We don't have angle measures here, so we're just going to count. 1, 2 for the base, 1, 2 for the height. So area is base times height divided by 2, which would be 4 divided by 2, which is 2. Now to get the area of the shaded region, we're going to take the area of the whole shape. That would be the giant square, the big square. And we are going to subtract out the area of the hole that's in the middle, that was the triangle, to get us the area of our shaded region to be 14 square units. No big deal. So let's do it again. We got the area of a circle. Area of our circle, if you remember correctly, is pi r squared. So our radius, 1, 2, 3, is pi times 3 squared. 3 squared is 9. So for now, I'll just leave it as 9 pi. The area of the hole that's in the middle is a rectangle. So the base is 2. And the side, 1, 2, 3, 4. So base times height. And when you write the area with circles, and this will come in a later unit when we do circumference as well, we're going to leave it in terms of pi. So when it says the exact value, you're going to leave it in terms of pi. So you will write your final area as the bigger shape of the circle, 9 pi, minus the whole of 8, and just leave it like that, 9 pi minus 8. No decimals, no rounding, no worries. Okay, so conceptually here, this is pretty easy. We had a bigger outside shape, whether it be the circle or whether it be the square, and then we subtracted the area of the inside shape, and that gives us the area that's left over. We're going to use that same kind of thinking pretty soon. If we have an odd enough shape where I recognize it, I'm sorry, I said an odd enough shape, a shape that's not odd, and I recognize the shape, what we can do is just find the area using the area formula. Now, do you recognize this shape? That's the question. I guess I can't wait to hear your answer because I'll never hear it. You're not here. It's a trapezoid. No matter how you spin it, this is a trapezoid. It has one pair of parallel sides, and the other two sides are not equal nor parallel. That's a trapezoid. So what we can do is take the formula for the area of a trapezoid and just apply the formula to our shape. If you don't know, that's okay. I'm going to write it down for you. The area of a trapezoid is the height times the sum of the bases divided by 2. You may have seen it or may see it as 1/2 the height times base 1 plus base 2. Remember that the two bases, doesn't matter which is which, but the two bases are the two parallel sides. So we can just count because they're drawn horizontally. 1, 2, 3, 4, 5. And then 1, 2, 3. We can count our height because it's vertical. 1, 2, 3, 4, 5, 6. Remember, the height is considered the perpendicular distance from one base to the other base. Since the bases are parallel, we just find the distance between those two parallel bases. That's our height. So now just plug in numbers into your formula. So our height is 6. Base 1 and base 2 is 5 and 3 divided by 2. That is 6 times 8 divided by 2. 48 divided by 2 gives us an area of 24 units. So if you recognize the shape, you can just use the formula, and it's so easy. Now for the triangle, area of a triangle is 1/2 base times height. Some people will write it as base times height over 2. It's the same either way. The issue is you just got to have your height perpendicular to the base, and then you can count. 1, 2, 3, 4, 5, 6 for the base. 1, 2, 3, 4, 5 for the height. Plug the formulas in. 6 times 5 is 30, divided by 2 gives us an area of 15 square units. So again, no big deal. So let's take it to the next level. Consider a triangular region in the plane with vertices 0, 0, 5, 2, and 3, 4. So graph your triangle. What is the perimeter of the triangular region? Oh, perimeter this time, not area. Okay, so perimeter. Well, perimeter is when you add up the length of all three sides. So what we have to do is figure out the length of all three sides, and then once we know that, we can just add them together. It does say that we are going to round to the nearest hundredth. So when we do our distance formula, in order to find the length, what we're going to do is at the end of the calculations, after we are done finding our three lengths, add them together and then round. You only round once and you round at the very end of the problem. Okay, so we can use the distance formula. The other option to try to make things a little bit easier on ourselves is maybe just make a right triangle where the hypotenuse of our right triangle is the length of the side we are looking for. So this was point O, 5, 2 with point A, and this is point B. So I guess I'll just do the distance formula because I don't think it's going to be very difficult with our points given. Side OA x2 minus x1 squared plus y2 minus y1 squared. Five minus 0 is 5. 5 squared is 25. This is a 2 minus 0 is 2. 2 squared is 4. So our length of OA is radical 29. Okay, so now we'll do the length of OB. So that'll be 3 minus 0 squared plus 4 minus 0 squared. So that's going to equal 3 minus 0 is 3, squared is 9. 4 minus 0 is 4, squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. So that's nice. Worked out nice and neat. And then our third side, which would be AB. Y2 minus Y1 squared plus X2 minus, X2 minus X1 squared plus Y2 minus Y1 squared ends up 5 minus 3 is 2, squared is 4. 2 minus 4 is negative 2. Negative 2 squared is positive 4. 4 plus 4 is 8. So AB is radical 8. As far as perimeter is concerned, perimeter is when we add up all the side lengths. Radical 29 plus 5 plus radical 8. It says round to the nearest hundredth, so I'm going to go to my calculator, add those all up, and round to the nearest hundredth. That is 2 decimal places. That's going to give me a final answer of 13.21 units. I'll write that neater, please. So our final perimeter is 13.21. So we use distance formula to find the length of each side, add the 3 sides together, bam, there's your perimeter. Looking on your page, it says part B, now let's find the area. We are going to use a method called decomposition, like decompose, slowly breaking away pieces. It's almost like digging for fossils, where you have a rock and you have to slowly chisel and hammer away at parts around the rock till you get to the fossil inside. In this particular case, our inside fossil is the area of the triangle that we are asked to find. So we want the area of triangle OAB. Now, unlike the areas that we did on the previous page, this one is not drawn with a vertical base or a horizontal base, and we can't count a horizontal height or a vertical height. So we cannot use the 1/2 AB formula. We can't use 1/2 AB sine C formula because we don't have any angle measures. So we need another new strategy. So our strategy is going to be to create the situation similar to what we did over here with our other examples, where we have a piece on the inside, a box on the outside, and subtract the two. What we're going to do is make the original triangle that was given, we're going to make that be the whole, and we are going to create a rectangle around it, and then we'll be able to find the area of the rectangle and subtract out the individual pieces from around the outside of that rectangle. And then I'll have the area that's left over as triangle OAB. So the first strategy or first piece of work that we're going to do here is draw our auxiliary lines around the outside of our given triangle in order to create right triangles with around each corner. That would then also create one big rectangle around the whole shape. So I created a rectangle around the outside of my triangle, and in that process also created some smaller triangles on the ins or around the outside. So you can see what I'm doing. I don't think I'm describing it very well. So what we're going to do, and this idea behind decomposition is very simple. We're going to find the area of the rectangle, the area of each of these three different triangles around the outside. We're going to take the area of the rectangle, subtract the three different triangles, and then what's left over is our original triangle OAB. That's the strategy we're going to do. And this is not very difficult, and it won't take long at all. And it's actually going to take less time than me talking about it and coloring it than to actually do it. So why don't I stop talking and get back to work. So I did the rectangle around triangle OAB and inscribed, find the area of the rectangle. Very simple. Area of a rectangle is base times height. If you go back to your graph, you can count that the base has a length 5, your height has a length 4, so the area of the big rectangle is 20 square units. When we drew the rectangle, we created the three right triangles. Number the triangles 1, 2, and 3 and find the area of each triangle. We want to label them 1, 2, and 3. That way your work shows me that you're doing the correct area to the correct triangle. So just to be simple, I'm going to label the top left 1, top right 2, 3. So make sure you have yours labeled because I have to go to a different page. You'll no longer see my picture, but you'll see your picture. Okay, so there's triangles 1, 2, 3. So the area of triangle 1, that was the blue one. Area of triangle 1 is base times height divided by 2, which is an area of 6 square units. The second triangle, that was the one on the top right, area of triangle 2. Notice how I'm labeling my areas so I can tell which is which. The notation is important so that you can show accurate work and the person reading your work knows which triangle goes with which calculation. 2 times 2 is 4, divided by 2 is an area of 2. So I told you this is going to go quick. And then the area of triangle number 3, base times height divided by 2. 2's cancel out, and you get just 5. Or 2 times 5 is 10. 10 divided by 2 is just 5. So now how do I get the actual area? Well, we're going to use what I call decomposition. So the idea behind decomposition, to decompose something or to break it down, sorry about that, to break it down is to take the area of the rectangle, which we had was 20, and subtract out the area of all the parts that we had around it. So the three triangles that we had around the outside of our original shape had an area of 6, an area of 2, and an area of 5. Those add up to be 13. So then the final area for triangle OAB, when I subtract that 13 from the whole rectangle's area of 20, we get an area of 7 square units. Nice and neat and totally complete. Okay, that's how you do it. So now you try. Answer key is on Teams. Check your work. You should have the answer key up, open, and in front of you as you do the practice questions and as you do the problem set. And that way you can check to make sure you're doing everything correct. All right, so that's 20 minutes. Have a good day. Peace out.